I'm Jeff Murray. I'm the founder of Meridian AVProConnect. And today we're going to talk a little bit about how to use our matrix switches to distribute 4K 60 444 with high dynamic range and wide color gamut and deep bit depth. This has become a necessity in the past year. Consumers are starting to see and adopt to HDR. So you as a custom integrator need to have a method to distribute this in multi-zone dwellings. Just a couple, before we go into this, a couple housekeeping notes. Tom Devine is on the call also. He's monitoring the chat line. And so if you want to type questions in directly to the chat box, go for it, and he'll answer them as we go. Or if you hold them to the end, we have a Q&A or a question period at the end of the presentation. Okay, so HDR signal switching and distribution. Now, HDR is everywhere. We use the term 4K 60 444, even though most of the content on UHD is 24 frame. So it's 4K 24 444, but 10 and 12 bit. Because the 4K 60 444 8-bit signal is the full 18 gig or 17.92 gig. So that's what actually is causing the issues out in the field right now by exceeding the capability of an HDBaseT extender. If you want to kind of learn more of the background on this, we did a whole hour on 18 gig systems, and it's on the link you see at the bottom of the page. It's a recorded webinar. You'll get this presentation in your materials for the course, and you can go ahead and click on the link and learn even more than what we're going to cover today as far as the background of where this 4K 60 444 is coming from. All right, so the system we're going to put together today is a 4-room apartment. The customer wants 4K HDR in all rooms. The distance is over 50 feet for 2 of the rooms, or 2 of the TVs to the rack. The distance is under 50 on the other 2. They have not decided on a control system yet. They've been discussing Control4 and Savant with you, but they're still deciding. So we're going to go through the whole process of manually setting up and configuring the switch to distribute 4K HDR with wide color gamut, and then we'll kind of layer in the control system at the end. The sources and the sinks, 4 displays, 4 sources, 1 AVR. Source is anything that outputs HDMI, like a computer or a player or a streamer. A sink is a TV or a projector. Repeaters, we're going to have our 4x4 HDMI matrix in there, and then we're going to have 2 runs of HDMI extenders. So our HDMI matrix is the repeater, and then we're going to have multi-channel audio in the living room. The other rooms are going to use TV audio, and then we want to conceal everything so that it's a nice clean install. So this is what we're going to hopefully end up with after we go through and configure this, a full HDR signal to every TV and then multi-channel in the living room. One of the big, I think, things last year at CD and probably the year before, it was there's no content available. The content is rolling out rapidly now. There's really advanced streamers out there that are doing better and better job with compression. They're external. They work a lot better than the internal smart TV functions, and they're easier to control. And then you have these game stations that are available, and then several different UHD players now are on the market that are capable of outputting this high-value signal. So high dynamic range defined expands the amount of light output and depth or color volume. So if you've seen it, and I'm sure a lot of you have seen this in the stores now, you get a much brighter picture, but you maintain the blacks. So you get better dynamic range. And high dynamic range actually is the #1 attribute to good video quality. So getting high dynamic range in televisions over the last year has made this drastic improvement in the quality of the pictures we watch. The wide color gamut gives us something much closer to human vision, and with that we get the deep bit depth of 10 and 12 bit. So we go from 256 combinations of red, green, and blue to 1024, and then 4096 beyond that with 12 bit. So there is a significant improvement in the video quality, and to be honest, a lot of the displays now are not capable of fully reproducing the new wide color gamut. But with quantum dot laser technologies, inventions coming down in the next 3 to 5 years, we'll get there, and we'll get to 100% of Rec 2020, which is your wide color gamut. We need to review this chart just a little bit. This chart, we call it the line of innovation, but if you kind of start at the left, you get type of signal, resolution, and there's a whole bunch of 1920 by 1080s, and there's a whole bunch of 3840s by 2160s. So this is where the confusion comes in. We have this 4K, 24, 4T0, 10-bit, HDR, wide color gamut, HDMI 2.0, 8.91 gig. A lot of guys say, well, okay, I'm under 10.2. I should be able to use UHD player, or I should be able to use my HDBaseT extenders, and I won't have any problem. The problem is this format, if you do happen to be lucky enough to own an Oppo, where you can tell what the native resolution of the disc is and the output resolution of the player, you'll see that this is native UHD disc resolution. This first highlighted line here. No TVs can reproduce that signal. The players, here we have most UHD Blu-ray players are all outputting 13.37 gig. So they're 4K, 24 frames per second, no color compression, 12-bit, and then HDR and wide color gamut. In gaming, a lot of the stuff is 60 frame, 444, 8-bit, and then of course anything in between. So if you kind of look between where I've got it highlighted here, those all exceed the limitations of a traditional HDBaseT extender over category cable. All right, so how do we go through this process? And of course, this is oversimplified. I know some of you guys are using, can't remember the name of the program now, but AutoCAD type programs where you can do designs for the customer and complete layouts. But plan out the equipment locations in the apartment, do your drawings, have your client interview, and get final sign-off from the customer. There could be change orders down the road, but you definitely want to get a final sign-off before you get going. Install all the products, mount the displays, run the cables, run the speaker wire, wherever you need it. Find a place to put the rack. Make the connections. Make sure all the cables are terminated, tested, and connected between the source, sync, and repeater devices. And it's good to do this before you do the first power up. If you start powering things up partially, it will go out and try to automatically calculate and decide what EDID to use. But it's better to do this once everything is connected up the way it should be, and then you do have a chance of getting EDID and auto functions in the displays and the switches to get the setup at least close to being correct, and at least getting a picture and sound out of every location. So on the first power up, after everything is connected, we'll let this thing self-configure with EDID. And then we'll go in and we'll start optimizing every source to output for the best video quality available. The reason we mentioned these two steps is because a lot of times the EDID will automatically set things up, but it will automatically set things up wrong to a lower resolution in some cases and to a different codec of audio and those type of things. So in our world, this matrix switch for full 18 gig distribution is the backbone of the system. These are three examples of switches we have. We're going to focus down on the 4x4 just for brevity of the class, and it's really just the same thing as you go out to more ins and outs in our device anyway. So there's three that the inputs are 18 gig and the outputs are 18 gig. Here's the one we're going to spend the time on today in the webinar. So this is our MX44 AUHD. Anytime you see AUHD on our products, sometimes it's SUHD, that means it's 18 gig. If we kind of go across the front of this, we got our display panel. We have our IR receiver, so we can control it with a remote if we wanted to. We have our input buttons, our output buttons. We have our audio delay, our scaling. And then on the back, we have our ins, our outs, our audio breakouts. We have each output or each connection has the potential of either an optical multi-channel or two-channel balanced or unbalanced stereo output. On the control side, we have the LAN or Ethernet, RS-232, and then we can also remote out an IR bud if we want to, running off 12-volt power supply. So that's our backbone of our system. Everything in and everything out is 18 gig on the HDMI side. So the control options that we have available, we could use the front panel buttons, and sometimes that works. You know, in a pinch, if you have access to the rack during setup, you could use the IR remote that comes with the matrix. You can also use that remotely if you wanted to, or use like a Harmony or a smart remote that you could learn from the one that comes with the unit. But the two most popular are IP control and RS-232. So here's an example of using the remote. Fairly limited capabilities. It allows you to switch inputs and outputs though. But this most popular one is using IP and just connecting it into your home router or system or to a WAP, wireless access point. Once you do that and you need to find the IP address, you can press down and hold buttons 3 and 4 on the switch, and you get the IP. The IP here is, you see it, it's 1.239. Let's go into that switch. So here's the 1.239, kind of a quick overview of the WebOS. So on this one, if I wanted to, and I could use this obviously with my iOS device, my Apple phone or my Android phone, I could hit this with the host IP address and I get this exact menu no matter what. So I can go in here and alias these if I wanted to put, okay, Apple TV 4K, output 3 is Sony, bedroom, possibly, or maybe I exceeded that, bedroom. Dining room, etc. And then when I apply them, they just automatically all show up over here. So bedroom, dining room. So here's, I could do some aliasing with inputs and outputs to make it a little bit more user friendly. They show up. I can switch either all or one at a time. I have my video scaling. We're going to go into all these in depth, so I'm not going to spend a lot of time here. Video scaling, image enhancement, and output signal generator for basic initial setup and troubleshooting. Some HDCP settings, audio settings for delay, audio matrixing, binding, or just separate matrix, and then turning audio off and on, and then managing the EDID. So we'll jump into each one of these separately as we go, but it really does make a really nice way to go through and set up your switch with a real simple connection to a router or to a home internet connection. So here's the options again. I showed you live. This is just another shot of the screens. Since you're going to get this in a PDF and you don't really have access to a unit unless you're already putting these things in. So there's the same screenshots I just showed you. And here's one I took this morning. You can see our office Christmas tree in the back. This is on my iPhone, and I was just demonstrating that I have full control of the matrix since I'm in the same wireless network in the building here, and I could do anything from configuration to switching to you name it. Okay, the other method of control is RS-232 control. We do provide a 3-pin Phoenix connector to 9-pin 232 adapter. So you may have to pull out your 232 to USB converter plug, but they're pretty much readily available everywhere now. If you're using 232, you can use a terminal program if you want, but we have a software program that you can download from our site, and you can run it, and I've got some screenshots coming up on how the 232 program works. Once you're connected with 232, you have full access, just like with IP, to make configuration settings on the device. So here's some of the screens. Obviously, COM port connection up here, and then scaling, out 1, out 2, out 3. And then video enhancement. That's the piece where I was showing you where we could do a little bit of edge enhancement on the image. And then audio matrixing. Here we have follow the output. It could be follow the output, follow the input, or separate matrix. And then on or off. De-embedded audio delay. Bypass means no delay, and so on. And we'll get into this a little bit further when we get into audio. Then you can mute. You can change your routing or your inputs to outputs. You have EDID settings down here, so you can pull in EDIDs, manage EDIDs, and then you have your full setup screen over here. So 232 IR direct control, free program for 232, and just use the IP address for your IP interface. All right, so the quick overview now, we've got everything connected, we've run all of our wires, we've done all of our great terminations. We know what we're going to be putting in. A couple of extenders over CAT. A couple of direct HDMI runs. And then we got audio breakout to an AVR to a multi-channel system with a sub in the living room. So now we need to talk about scaling, EDID management, and audio delay. Scaling, EDID management, audio delay. So the number one is scaling. Scaling if you've been around a while, you know we've been using scaling in video forever. And normally it has to do when you have a mixed system, i.e. 1080p's and 4K displays, or early 4K displays and current 4K displays. If you don't manage it properly, a 1080p display or a 720p display in an unmanaged system will cause every display in the system to downclock, even though it's capable of 4K. And I know you guys have probably all heard that before. We put scaling on every output on our matrices, and that is for that very reason, is to deal with mixed systems, which I think are the norm. So you can upscale, so 2K to 4K, and you can downscale 4K to 10 to 2K, or you can just put it in bypass mode and let everything run normally. Especially if you knew you had a full 4K system, sources, sinks, repeaters, you just leave it in bypass. You can set scaling and audio delay. Again, they're both tied to the output. You can set them right from the front panel control over here. Or you can set them with IP or RS-232. In IP and RS-232, here's the screens. Here's the real screen. If you notice here, they're all in bypass mode now. I have all 4K TVs, but I could have the output set to 2K, the output set to 4K, or the output set to HDBaseT or auto. If I set it to HDBaseT, what that does is that takes and does our ICT compression. ICT is invisible compression technology. You're going to see that when I talk about some extenders and some of our matrices with built-in HDBaseT. We do use the HDBaseT transport mechanism, but we do light compression. We take and do color compression from 444 to 420, and what we can do is we can non-destructively compress the colors to get the signal down under 10.2 gigabits, so it can travel through that HDBaseT extender set. If you have to convert it back, which you would on the other end, in this case you could use our SC1. It's a small EDID minder scaler, very, very low cost. You could use that in front of the display to decompress that signal that was compressed with this ICT or HDBT compression. Same things are available on 232, just a little different user interface. Okay, so the next thing is managing this beast called EDID. EDID causes about 80% of our tech support calls here at AVProConnect. That's why we highly recommend you use our switching and you use our testers, you know, the Meridio stuff, the Fox and Hound, and the 6A6G. But the way EDID works is EDID, or now it's called EDID, Enhanced EDID, is communication from a sink, which is a TV projector repeater matrix, to a source. So it's a one-way communication. The display sends EDID to the source. The source can only read the EDID. So there isn't really any two-way communication per se. The TV says, here's what I need. I need this. This is my preferred format. You can see a little kind of a little piece of it. Hey, I'm a Sony TV. I prefer you send me 1080p, but I can handle 4K. I can't handle HDR, blah, blah, blah. So, you know, EDID has been touted, and it's been around for a long time. It's actually a VESA thing. It's been around with computer monitors and things. And now with Enhanced EDID, it's supposed to figure out the best way for devices to talk together on the network. Unfortunately, what happens is the TV can only send the EDID one level. So what happens is we always use repeaters, right? We're in the world of custom AV. Repeaters are AVRs, they're matrix switches. So the TV sends the EDID and it's intercepted by the repeater. If the repeater is not configured properly, it'll send the wrong EDID, like with an AVR, to the source, and that's where you get things like purple screen, pink screen, color space mismatch. You get audio dropouts. You get two-channel when you're supposed to get multi-channel. Excuse me. You get the wrong resolutions. There's a lot of issues, or even no picture. So we need to be able to manage this situation. When we're doing a multi-zone dwelling, and we have lots of inputs and lots of outputs, this EDID management becomes critical. So how do we do it? EDID's tied to every input. You can select it from the drop-down menu. I'll pop over to the live one now. So here's a whole laundry list of what I call canned EDIDs. So if you know what's in the system and you can do a direct canned EDID, normally you can return to picture and audio that you want. If you look at, we have about 40 of them in here. We have 3D, we have different color space, we have multi-channel to two-channel, we have HDR, we have 3D versions with HDR. But then even better than that, if necessary and if it's possible, we can also copy the EDID from the output of the display itself. So that's what that just did. That just copied the EDID from the display, and it put the display EDID in line with that input device or source device, and now we have a much better chance of getting the right picture and the right audio on the display. Sometimes you got to force it, like used one of the canned EDIDs because maybe the TV just needs firmware and it hasn't been spun yet, or it solves a lot of problems trying using these canned EDIDs. Even with a tech that maybe is not so sharp, they can still run through and select these EDIDs and find one that's gonna work and optimize the way that television performs. So I can go ahead and do this along for each one of my inputs, and I'm done. And I can ensure that I have, audio and video to every display. If the matrix fails to copy the EDID, it's usually because the TV is turned off or there is some kind of a hardware problem with the TV. If it is, it'll go back to one of the canned EDIDs like you see down here below. Same thing here. You can do all the same functionality with the RS-232 connection. Next thing we're going to talk about is audio delay. What happens when we separate audio and video like we do in custom AV, and we run into, for instance, Sonance multi-zone amplifier, two-channel type systems. A lot of times the video takes longer to process through the system than the audio. So we need to delay the audio so the video can catch up. With all of our switches, we put this in the system for you. And let's take a look. So in here, we can go from 90 to 630 milliseconds of delay and everything in between. Now, you can do that with either, watch the video, watch the lips and, watch the video, listen to the audio, or you can look at one of these Sync 1.2 devices. We actually sell these on our AVPro site, and you could that's a tester. I think it's about $400 or $500 that actually can give you accurate lip sync delay testing and correction. But if you're going to do it by eye and by ear, you can use the front panel buttons and just scroll through the different settings until you get one that is as accurate as you can make it by eye and by ear. Another look at the screen in both RS-232 and IP. While we're on the screen, I'll show you the rest of the audio functionality. So you've got the delay, of course, here in the middle. Then you've got audio status. That's where you can just turn audio off or on in a zone. And then you have the audio matrix. It can be bound to the output, bound to the input, or it can be a separate matrix. So that gives a lot of functionality. It literally gives you a separate matrix switch for audio with all the switches that we manufacture. So basic settings here. So a little bit more about audio management in this system. As a reminder, 3 of the TVs are going to just be getting their audio from the speakers in the television. So real simple. One zone is in the living room is going to have an AVR connected, and it's going to be a multi-channel system. What's available on all of our matrices is balanced and unbalanced stereo via 5-pin locking connector, sometimes 3 and unbalanced only, or multi-channel via SPDIF optical port. Both ports are active when in stereo mode. Of course, once you get above stereo, your stereo port is not going to know what to do with that. The AVR should be set up, in this case, for the living room via SPDIF. Connection to drive Dolby Digital or DTS 5.1. That's your full surround sound. So the matrix, or the audio part of the internals of the matrix, they basically take what comes in and send it back out. There isn't any conversion within the matrix itself. At this point, we're a recent Dolby Digital and DTS licensee in the last 6 months. So our 2018 roadmap is we will build these in on a zone-by-zone basis. And yeah, it's going to cause the price to go up a bit, just with licensing fees and everything. But if you do need to downmix to 2-channel stereo from Dolby Digital or DTS, you can use our ADM-AUHD. It's a box that actually does a downmix for you, and it's fully Dolby compliant. Let's see if we can find that. There we go. So it'll take an 18 gig HDMI in and HDMI out, so you kind of put this in line so you get that full signal out of the matrix, and then you down mix it with a Dolby or a DTS decoder that's built in. web link there. That way we get we get our regular TV audio here, and we get multi-channel in this room, and everybody's happy. Excuse me. So a quick look at how the connectors actually physically connect. The 5-pin, it comes with a, or it may be an accessory. I think it comes with it, but it's a 5-pin Phoenix to RCA, so you have an easy connection into your AVR. And then you have a Toslink that you can easily connect into your AVR. So that's your 2-channel and multi-channel options. And then just another slide showing that this is very, very important. You can bind to output, bind to input, or matrix the audio. Then another look at the down mixer. If you do need to down mix Dolby DTS signals, you need to use a device like this in the zones where you need it. And it's just inline, real simple connectivity, but it does solve a lot of problems, not even just with matrix switches, with other applications that I'm sure you can think of. So now that we've kind of looked at delay, scaling, EDID management, let's talk about getting that signal there. So there's a couple things you can do in extended 18 gig. One is you can use our EX40. So this is the EX40-444. We have these in 70 and also 100. And those are full 4K 60 444. The 70 and the 40 are fully shipping. The 40 has IR RS-232 on it. The 70 adds a couple Ethernet ports, and the 100 adds ARC on top of that, and of course the distance. So your 40 is 128, 70 is 228, and 100 is 328 feet of distance over copper using our ICT compression technology. So we get a full 18 gig in, full 18 gig out. We also have a brand new product, which is called the EXO444 kit. That is extended optical that does the full 444, 300 meters at 18 gig using multi-mode fiber, 2,000 meters using single mode fiber. And it has ARC, which is another one that some of y'all ask about quite a bit. But again, fiber optic, we recommend on this Clearline fiber. Clearline is stronger, safer, faster. It's easy to terminate in the field. And when technology does change, then you'll just have to change endpoints as things grow. But this will handle and produce a very, very clean full signal with high dynamic range and wide color gamut over, you see, some significantly long distances. And I think you'll be surprised at the price on this for fiber. I mean, it's really, really dropped significantly in the past year. We can also use active optical. You hear them called AOC. We have a full line of them up to 40 meters. These are terminated HDMI on both ends. Metal jackets, very flexible on cable reels, part of our bullet train collection. Then And for the shorter runs, under 45 to 50 feet, we can use passive cables, well-made passive cables. We do these from a 1/2 meter up to 15. 15 is a big, thick, flat cable. It's a little pricey, got a lot of copper. The 8 and the 10 are a little thicker than the 1/2 to 5, and it's just because of the tightening of the spec and to get the full 18 gig through the system. And then when you use those type of devices, it's always nice to be able to rack mount with airflow and use single power supply versus several power supplies. Touch a little bit on the extender zones. If we want, on the extender zones, we can use IR. All of our extenders, no matter what, come with the buds for receiving and for flashing a system. One thing that we put on our extenders that's really nice, we have IR in, we have IR out, but we also have iPass. iPass is a 3.5 millimeter auxiliary jack that connects directly into the control system. So you don't need to do octocoupling or anything like that. You just get a nice clean connection. With the IR, then of course you can control the set-top box in the rack from the bedroom or the living room, or vice versa. From the rack, you could actually turn the TV on or off if you had it set up that way. So there's a lot of different applications with IR control using extenders. At this point, you've got everything set up. And I mean, that we just kind of did it the manual way. So you can go through like the WebOS or RS-232, make sure every display can output the full 4K with HDR. Audio delay is set correctly, EDID set correctly, scaling if necessary is set. Little thing at the bottom, if you haven't already got a Fox and Hound troubleshooting kit, it really does make things go faster when you're installing a system. So most of you are going to probably put in a third-party control system. So you'll be happy to know that we have all of these different drivers available. Let's see here. Right here. So we have IP and serial or RS-232 drivers for Control 4, RTI, Crestron, Savant, and others. So those are all just a free download. These are, for the most part, these were all done by Janus Corporation in the UK, so they're extremely robust, well documented, easy to follow instructions, and easy to implement. We also have a technical staff here that can help you if you run into issues. So now we've got everything in place, everything is configured in the matrix, and now we have a happy customer. So AVProConnect has the connectivity products to handle HDR. We have matrices, extenders, DAs, scalers, EDID minders, and audio down mixers, all rated at 18 gig. All you need to do is make sure that the AVR, the display, and the source are fully capable of handling those high value, high bandwidth signals. And not to mention the HDCP 2.2. Here's some examples of our uncompressed switches, HDMI in to HDMI out, all shipping, and then our HDBaseT models. 4x4 is shipping now. These can, and this one is shipping on around December 18th, the 8x8 down here. And I know those of you all who are on this who are saying, well, Jeff, I've heard that before. Yeah, this one is a bit delayed. But it was, there were some issues that had to be dealt with and some extra programming that had to be done. You can see these have routable IR on them that works in conjunction with the HDBaseT. These HDBaseT ports, those use our ICT compression. So the ICT compression gives you an extended length of up to, I think in this case, 228 feet over 8 category cable to one of our 444 receivers. And the receiver then reconverts the ICT compressed signal back to the full 18 gig on the output and the input to the display itself. So these make a nice cleaner install. The other functionality is pretty much the same. 18 gig on the input side on both, audio de-embedding, SPDIF connectors. The other thing is you've got mirrored ports, so you've got 18 gig HDMI port and then ICT compressed HDBaseT port, and that's also switchable. So if you don't want to do ICT compression, you just want to treat it like a regular HDBaseT extender, you just switch it off. Again, this one's going to be shipping to you around December 18th. We expect the first batch of these to go really, really quick, but there's several on back order now, but just hold on. You'll get these in the next 2 weeks. All right. At this point, I'll entertain any more questions. Tom's probably going to pop in here. Do we have any questions, Tom?
Sure do. All right. First question. If you have a 4K source going into a matrix, AVPro matrix, and you want to distribute Dolby audio to a theater driven by an AVR, and in a few zones you want 2-channel audio, would you need additional hardware, or would the matrix alone be enough to manage it?
If you want to go multi-channel into an AVR, you just go into the AVR with the HDMI connection, and you get multi-channel. And then again, it's going to be it's dependent on the source and the displays and all the zones though. So if you're using just a straight HDMI cable, that's what you're going to get the multi-channel on, and the 2-channel to those systems would be available via the de-embedding feature. But again, it depends on the source, because the matrix itself distributes the audio signal that comes into the matrix.
All right. And then another question is, how does this this way of doing it compare to AV over IP as far as features, pricing, such as products like just Add Power?
Okay, so how does this compare to products like HDMI over IP? Well, the number one thing is there is no compression, if you will. There's ICT compression if you use the extenders. Of course, if you use the fiber, there's no compression. Think about HDMI over IP. you're running that through either a gigabit or a 10 gigabit switch. If you're running it through a gigabit switch, you're compressing 18 down to 1 to get it through the system, which does cause artifacts, especially if you use a larger screen. You know, most of these demos you see at trade shows, you'll notice they're on 32-inch and below screens, and usually even smaller, because once you blow that up, you will see artifacts. So HDBaseT and HDMI are the way to go for uncompressed video distribution at the full 18 gig, so you can reproduce the signal the movie maker wanted you to see.
Next question is, are there two-way drivers available? I don't know what that means. Two-way drivers?
I don't know either.
Okay. I'll ask him if he has any.
There was a question about two-way drivers, and we're not clear on what that means. So we're going to ask you for clarification. We may have to get with you afterwards, and that might be a Matt question. Okay, let me pop over to the next slide. So we talked about the Fox and Hound troubleshooting kit a little earlier. There's a link to that in your student materials, and there's our 3 websites. We do offer worldwide training in video and 18 gig distribution, video calibration. You can see that at avpro.training, and we also sponsor Home Acoustics Alliance audio training and THX video training. Okay, a couple more questions came in.
Do the AUHD matrices pass Dolby Atmos?
Do the AUHD matrices pass Dolby Atmos? HDMI, if the source is HDMI and it goes through HDMI, we don't do anything to it. So the answer would be yes. We don't down mix it though. That was a question in the last group. We pass what's coming from the source.
And then one of our other integrators chimed in to say, yes, we have two-way drivers. Our Control 4 driver is a two-way driver.
Okay, good. Okay, on the two-way driver, somebody chimed in and said that Control 4 drivers are two-way drivers. So I'm going to say that we do have or support two-way drivers. All right, and we don't have any more questions. I really appreciate your attention today, and thank you very much.